Hello guys, now we come to our exercise lid-driven cavity. And before we start, please look in the exercise and look at the description. You can also look how a lid-driven cavity problem is looks like, what is the setup, and in general it is a really easy grid, and it's a really easy geometry. It's just a block here. But in this exercise we want to do different mesh sizes, a coarser mesh, medium mesh and finer mesh. And we want to check also the theory if we can fulfill all the demandings, and it is a test for viscosity. I told you in the lectures that the change in the viscosity in the temperature, change in the temperature of water will cause different viscosities, and we want to have a look how big the influence of viscosity is on the fluid flow inside this example. So the geometry is not so difficult, but we want to learn something about mesh sizes, and we want to learn something about fluid property viscosity. Okay. So let's look at the geometry. Looks rather easy. It's just a block, three-dimensional block. Or we can make hexaedral meshes that will fit best. And let's say we take the size of 1 meter. Okay, I think that's the easiest choice. Okay, let's have a look at the ANSYS Workbench. I will open the workbench. Wait a second. And here we are. You can see the workbench, and I will make the picture a little bit bigger. And here I go to full screen. So now you can see everything of our ANSYS Workbench, and I graded up a bit. I graded up to the new workbench. You can see it here about ANSYS Workbench. I graded up to version 2020 R1 and to the student academic version. So I think all of you guys have the same version now. You can check it. Here is our toolbox again. You can scroll up, scroll down the toolboxes. You can see the different component systems or design exploration tools. Or you can see the analysis systems. There is a lot. There's an engine. You can make a magnetic simulation, structural simulation. But here we are we just want to deal with fluid flow problems. So I push the left mouse button, go to fluid flow problems, and I drag my problem to the project scheme. Here now you see fluid flow CFX. That's the tool we want to use. You can create geometry, you can create a mesh, you can define your setup, let your solution run, and visualize your results. Okay, that's fine. Now we start our lid-driven cavity problem. And first thing I want to do is to save my case. And now it's really important that you save it here under the workbench. Don't save it in the single tools. That will cause a bit mess. Just save it here as file, save as. I go to my directory, and the name should be lid driven cavity. Okay, and maybe version 001. Maybe I change a bit of the versions later. So I save it here, and now I will create the design of my geometry, and don't be afraid, it's real easy. It's the easiest geometry you can do. Now go to geometry, right click with the mouse, so press the right mouse button to come to the menu, but please don't use space claim here. We don't want to use space claim. That's an alternative measure or geometry generator. We want to use design modeler, new design modeler geometry. Never use space claim, use design modeler. Otherwise you will get a different setup. We press here, and now it takes a while. You have to wait a bit, yeah, until your design modeler opens. And now here is your design modeler. You have the tree outline and the modeling folder. You have the sketching folder where you could sketch something. And first step, we have to define our XY plane. And to define it, I press here XY plane, and now I start drawing my geometry, and I told you it's nearly too easy for you. It's just 1 meters. We go to sketching. We take the rectangle tool. We press it. We start here at this point. We drag our box about as you like. It don't have to be exactly 1 meter. And now we go to extrude. We press extrude, and here you can see first impression of your geometry. And the extrude should be, let's say, 0.5 meters. .5 meters. Yeah. Now this is an error message. Never use point. Use comma, because this is now German setting and decimal separator setting. So you have to press comma. If you have other settings, international settings, English settings, you might use a point or dot. So let's press generate. And here you see your first geometry, create geometry. The size here of this aquarium, of this tank, is about, it's about 0.5 meters, but the other dimensions are not 1 meter. Now we want to do it exactly that every side here has a length and a height of 1 meter, and you do it by sketching. You go to sketching, you choose dimensions, and you go to horizontal. Presses 2 nodes, and now we have a new dimension here, h1, and you can see h1 here is now 1.7704, and I enter this field. I enter 1, press generate, and now the size is 1 meter. So second step is you have to change the vertical size. Press here, enter, press 1, up, and generate. And now you have your box, your water box, your lid driven cavity box. Okay, and now this geometry is nearly finished. But one thing is missing. I go to back to the modeling tree, and I told you it should be like an aquarium, a box with water inside, yeah, with 2 different temperatures, and we need a movement of the water. So imagine we have a moving wall here at the top, yeah. Imagine we have like rubber band or so that is moving in high velocity here at the upper wall, and this will cause our swirl. So we need some velocity. And here I go to selection filters here at the upper corner. Maybe before I start I press generate. It's always good to press generate from time to time. Now I go to the selection filter. I want to choose my face until it's highlighted in green color. Now I press the right mouse button, choose name selection to apply, and here is it's a name selection. There's a small flash left. Go back to generate, and now here's the flash is gone, and I enter rename, and we call it moving wall. Moving wall or rubber band or moving boundary condition is fine name. So you can check, always check, try to click a bit on this element, check if everything is here and if everything is fine. Okay, looks good. Now please take into account, don't go to save here, don't change the path of your models, otherwise you will maybe you don't find your model anymore. Just close the tool, the design modeler, check here the tick at geometry and in your workbench, and here under the workbench you go to save project. That's fine, that's pretty fine. Now you have your geometry, and we go to the second tool. We go to mesh and choose edit. Okay, it's good that we have the new version, the 2020 version, and before now it opens, and you see the new design of the ANSYS 2020 R1 version, and we have our model. Okay, takes a bit time, don't be too fast. Let the program open everything. Look, go to mesh, nothing is generated, so I press a small button with a flash to generate my first mesh. Okay, looks pretty good. I think this is my first mesh. Looks quite really good. But the idea of our exercise was to check different meshes. You should check different meshes and should check how they influence the results. So I go to sizing and maybe statistics. Okay, you see we have about 1183 elements, so it doesn't look so much, but it's quite a lot because it's a three-dimensional case. And okay, now I want to just have a small look what's new in this menu. Okay, now I want to insert a sizing. I go with the small finger to mesh, right mouse button click, insert, and I choose sizing. So now I can change the sizing of my mesh, but before I can do it I have to tell the program which geometry I want to change. Maybe someone has more, we only have one now. If you have this yellow field here, you have to do something. You press your left mouse button, go to this body selection mode, choose the geometry, go to apply, and now you're applied your sizing, and you go again to generate mesh, and I think this was wrong. Sorry, it was a wrong choice. Delete the sizing again. We don't need this feature. Change the menu, change a bit on the new version. So I go back to Insert, Refinement. Let's check this. That looks better. Again, I have to choose Geometry. I press this yellow field and changed a bit. Not sure if this is right. Let's delete it. Now, take method. Maybe it helps. No, doesn't look good. I delete it again. Go back to mesh and try again sizing. Let's check it if it works. Generate. And yeah, that's the right choice. That's okay. I have to choose sizing, yeah, mesh, body sizing, element size. Let's look, what is this? I think element size is a good choice. I go to element size and I want to use a global factor. That looks good. Global factor is 1. We have again our 1180 nodes. Now I change it a bit, change it to 0.7. Don't change it too much, otherwise you will get a lot of cells and we want to prevent too much work for the computer. Okay, that was fine. That was right. That's what I wanted to do. Now we have more cells here. Okay, looks pretty good. We have now a really fine mesh, but now I can change this factor, but now I want to take one with a coarser mesh. Maybe take 2 to check this feature. Now it gets pretty coarse. Yeah. Okay, look into the statistics. We only have about 100 elements now, 147. It doesn't look so much, but okay, why not? So we change it back to 1. Was a good mesh size. Generate the mesh, and now it's pretty fine. We're finished with our mesh, and here again the same. Maybe we try it. So you can save, but you can also just close the model. Go to disk, copy. Yeah, here again is this small flash. Doesn't matter. Just go to update. Wait a bit. It takes some time. Now we have our first mesh, and the mesh is also a lot of data. You have seen it's about 1100 cells, 1200 nearly, and so you need a lot of space for your memory and so, but now it's finished. Okay, here is our setup. Now we go to setup, right mouse button click and choose edit. So not a problem, it's just a Windows problem. The firewall does not agree with something. Just go to Zulassen and start it. So here we are again, and we are in our CFX pre-tool to define the setup. Here you can see our geometry. Try to rotate it a bit, try to move it a bit. You can press your mouse wheel to rotate the 3D geometry. You can scroll your mouse wheel to use zoom functions. And if you now click here on CFX CMDB, you see your mesh. It should be highlighted in green colors. Looks good. So now we have to define the boundary condition and have to define what we want to do. And we wanted to change here the velocity at the side of this okay. To check what we want to do, we want to go into Kahoot, Moodle, maybe we'll look at the exercise sheet. Wait a second. Okay. Okay, wait a second. Try to find it. Oh, okay, I was on the wrong computer. I'm very sorry for it. I go back to my exercise here, lid-driven cavity, and I check the velocity we want to use. Okay, we want to have 1 meter per. We want to have 1 meter U. The velocity should be 1 meter per second. Okay. And we want to use water with 50 and 75 degree, and we want to have coarse, medium and fine mesh, and check the differences. Okay, it has not to be exactly this size, just make it as you like. Okay, now I can go back to our go back to our screen and change it. Okay. First, we go to default domain. Here, you double click it, and you have to define your fluid, what you want to use. Here you see this default settings are air at 25 degree. Yeah, that's not what we want. We don't want to make a simulation with air. Maybe we do this later. We want to make a simulation with water. Yeah, we choose water here, and if you want to choose other libraries, you can choose many different types of fluids. Yeah, you can use soot, particles, you can use aluminium, copper, steel. You can use a lot of fluid properties for also for fuels, yeah, for gasoline or diesel or oil. I will introduce this a bit later to you, but here water is fine. And we said we want to use water with 50 degree. Small check, cross check. Okay, 50 degree and 75 degree. Okay, perfect. So I choose water, and here you go to fluid models. you choose isothermal. This means in the whole block there will be one constant temperature. And I choose 50 degree. And please don't forget to press the apply button here. Otherwise, if you go to another folder, it will not be saved, your settings. Okay, and as a model, we use K-epsilon model, turbulence model. That's pretty fine. That's the easiest model. We can use it. Initialization, we don't have to do any initialization. We go to apply, and now we have defined that we have water. But we have to do another thing. We have to introduce a moving wall. We go to insert boundary and we call it moving wall or rubber band or something like this, or chain, and we choose a wall. We have to type boundary type wall. There are also others: inlet, outlet, symmetry. Don't mention it, just choose wall. And now I want to have a wall movement. I go to boundary details. From time to time press apply to make sure everything's safe. I go to here and I want to choose a wall velocity. And now you can enter wall velocities in every direction. And if you go back to your screen here, you look here at your coordinate system. We have an X direction, we have a Y direction and a Z direction. And now if we come back to theory of CFD, I want to mention that the U direction is always in X direction. The V velocity is always in Y direction, and the W velocity is always in Z direction. So if you change U velocity, you will have a movement in X direction. And our idea was to use 1 meter per second. I go to apply, and now I get a small error message. You have left some empty fields. Go to OK, press 0, 0, and press apply again. And now I have all the 3 velocities here. 1 meter, 0 meter, 0 meter. So we have a movement here in this X direction of the wall. Go to OK. And we have only water inside, no air or something like this. And you can also check the ruler at the bottom. We have about 1 meter. Though our example is finished now. If you want, you can also rename the default regions to wall, but you don't have to do it. Maybe check it, make cross check. No movement at this walls. Okay, now we are finished. Please don't go to save. Don't save it somewhere else. Just close the pre. Okay. Close it. And you can go to solution. And here at solution, use just update. Don't use edit. Don't use anything like this. Just go to update. And when you want to run the simulation, please make sure that in your installation path or in your working path you don't have German symbols like Ü or Ä or Ö. This will cause errors. Okay, you see the computer is pretty fast. Yeah, I have a good machine. The solution is quite here. You can go to display monitors and you see your solution is finished, more or less. Yeah? And I can show you I have a really fast computer. Go to Task Manager, open the Task Manager, go to more details, and CPUs. No. Wait a second. Resource monitor. And you see CPUs. For me it's no problem. I have a lot of CPUs. I have about 11 CPUs. So the simulation will be pretty fast and my computer takes not much time. Now here's a green tick. You can go to results, edit. And again, the screen opens. Just go to check this button. And now we are at the post processor. And this is a graphic tool. It's like a painting tool. You can make visualization of your results. And the first thing I want to do, I want to see if something is moving inside. So I enter the streamlines and I start from everywhere and I start forward backward. I go to apply. Wait a second. And now you see our swirl. That is our first swirl. We have a moving wall here at the top. Maybe I highlight it a bit. This blue region is moving. All the other things are not moving. And you can see I have a nice swirl of our water flow at 50 degrees. So I don't like the legend here too much. It's not so easy to read. And if you want to change the setting a bit, you can go here to default region and I change it from scientific to fixed point, and now you can read it a bit better. Okay, maximum velocity inside the fluid is 0.288. And now if you have small if you look into the slides of the lectures and remember the how we defined the viscosity. If we have a gradient, if we have a high velocity here at the wall and we have a gradient inside the fluid, and then when you know dynamic viscosity, we can directly calculate the shear stresses and the turbulence inside this fluid flow. So, and I told you, you always should document your work. That's important if you want to work as an engineer. So you have to present the results. Okay, that's what we want to do now. I want to teach you a bit. Please go to PowerPoint. PowerPoint might be the best tool for this presentation. Always have to document, and you can choose. Now, open again, PowerPoint. Okay. Yeah, I want to choose nice setting. For example, this one. Okay. It's not so nice. Okay, that's a nice design. It looks pretty nice. We need the title. We use this field and we call it lid driven cavity example. So like this. Perfect. Make it a bit smaller. It should look nice. And we make our first screenshot of the post here, like this one. And I make a push it a bit near to the legend. That's fine. and we make our first screenshot. Oh, like this, and make it a bit smaller. Okay, I crop it. I place it here. It looks pretty nice. And of course, you have to remember what you did. Please write a title here. Write which media you used. Maybe lid driven cavity test case. Water with 50 degrees centigrade, or let's write it with T, 50 degrees centigrade, like this. Okay, and we also want to mention the mesh, and let's say this is medium size mesh used. Okay, that's pretty fine. And now that I save it, save as, maybe here on the desktop. Okay, and now I want to change the temperature. I go back, I close this tool, close it, and all the settings will be saved. I go back to the workbench, I go to setup, I edit setup, and it will take some time. And then I go to default settings, double click, fluid models, isothermal, and the idea was to make the next simulation with 75 degree apply. But meanwhile, I also had the idea to make a picture of the mesh, because I want to show the audience how big my mesh was, and this is a good chance. I press print, I make a screenshot, I go to OK, close this button, go back to my PowerPoint, insert the screenshot, copy the slide, and now I can do some information about meshing also, like this here. Well, maybe I copied the wrong. Copy this back, and I delete this, and this should be my medium-sized mesh. I do not need this information here. Okay, that's fine. So I have my first mesh picture, and I have also enough space for all the other meshes. Yeah, and here I use this medium mesh, and now I make the second simulation. I go back here, maybe go to save, solution, right click, and now be careful. This is the old data is your 50 degree simulation. I want to clear this data. I want to make a new update with a 75 degree centigrade simulation, and let's look at the monitor. My CPUs are running pretty fast. Yeah, here you see the load of the CPUs. So pretty fast. So the solution is here. Go to edit. Wait a second until post opens. And all the graphic features I used are back, but the temperature now is 75 degrees. And let's make a screenshot again. Okay, this now looks pretty much the same. Maybe we should check what we did. Go here to, I want to check if I have the right temperature. I insert a plane. Apply. And I go to temperature. Okay, now we have Kelvin 348. Okay, that's our 75. That's fine. Okay. Maybe we use a plane. Insert a new streamline. Now we can make again a screenshot, insert it here, and what we see that we do not have big changes here. Okay. Not much changes yet. Okay. What is wrong? What was the problem here? Okay. Let's go back. Maybe. We go to setup, edit. And we have to introduce another material. And I want to import library data, water data. And now I don't take a special water type, I take a real water model, insert it here, and here we have change fluid properties, better fluid properties, better viscosity properties, and now we can go to default domain and we choose the real data for water. And we take this, again, this 75 degree. We close it again. We let our solution run. Press update. Now it takes some more time. Please notice simulation was a bit longer now. Go back to edit of the results. And now we see the results change totally. Though that's a better picture, I press print again. I delete this sketch here. I insert the real 75 degree simulation with the fluid properties, and I think I have to change the 50 degree also. Let's do it together. Go back to Workbench, Host, we close it pretty fast. We go to Setup, Edit, and now we go to default domain, fluid temperature 50 degree, OK, press apply or OK, close it again. Don't forget to delete all the data here. Go to solution. Oh, there's no old data. Okay, why not? Go to update. Wait a second, it takes some time. Let's look at the CPUs. One CPU. Yeah, there's our load. The solution is here. We go to edit of the results. And now we should have our 50 degrees centigrade results. I make a screenshot, go to PowerPoint, delete this graphic, and it's smaller. I crop it. Okay, looks pretty fine. Crop it. And now we have two different results. This is the lid-driven cavity test case with 50 degree water, and this is the lid-driven cavity test case with 75 degree. And what I teach you before, if we have colder water, the velocity is a bit yeah, the viscosity should get higher, and if we have higher temperatures, the viscosity should get a bit lower. So if we have a higher temperature of 75 degrees centigrade, you can see here at the swirl, yeah, the influence of the moving wall onto the water is not so high, and if you have 50 degrees it's much higher. But something is missing. I want to tell you something about boundary conditions, and best case is to do it with a good arrow. Yeah, let's see, like this. And I type in the boundary conditions u equals 1 meter per second. Yeah. Let's take a small u. Now it's too big. Make it smaller like this, and maybe change the color to this cute green. Okay, so that's our moving wall. That's pretty fine. Okay, that's it. Let's repeat the same examination for a final mesh grid here. I go back to, don't forget to save your slides from time to time. Now I go back, I close this again, and I want to do the same experiment for a bit finer grid. I go to meshing, edit. I go to meshing. I want to make it 0.5. So generate mesh. Have a look. You see, it's much finer meshes. So I go to close, update. It takes a bit. Now that we have a finer mesh, we need more time to update this mesh. You can look at the CPUs, goes some time. You can go to setup, edit. And it looks like this. You can make a screenshot here. Don't have to change anything yet. We take the 75 degrees centigrade. You can enter it here, your screenshot. Oh, like this. It's pretty nice. Everything also for the coarse mesh, and we copy this one and we will need it later. So let's go back to the workbench and update everything, and I go to PowerPoint. Meanwhile the simulation runs. I can prepare my slides a bit. Always save it, don't forget this. And we go to test case. Now we change this to 75. We change this to fine mesh size, and we delete the picture. We save it. Okay, let's have a look at the workbench. It's over. Have a look. Look at the CPUs here. If you look at your load of the CPU, you see it's a bit more, yeah, because the mesh was much finer. You need more simulation time. I go back and open the results. Make a screenshot, copy it to PowerPoint, make it a bit smaller, and crop it. And now you have your fine-sized mesh result and your medium-sized mesh result. Okay, now you can try to do this, the last mesh, the core size mesh examination on your own, and I hope you enjoyed this lecture and you've learned something, and we see you in the next lecture.